Hello, this problem is what is the total duration in minutes for the recorded lap times? And then we have a table here, and the table has 12 values. So if you thought to sum all of these values, that's correct. But when we go to list these in a very tall addition problem, it leaves the room for a lot of mistakes. So when we list them vertically like this, we might find that adding them together, adding all of these one or tenths place values together and then carrying it and adding all of these ones place values might create a problem in which we make a lot of mistakes. So I wanted to show you a way that I like to do it that helps me solve a problem like this. It's just simple addition, and you already know how to do this, but we can break it down into smaller steps so that we're less likely to make mistakes. So the first thing I do is I will take, I'll take the first two numbers, and this is kind of an arrow that I'm drawing, and I'm going to add these two numbers together. So the 4 and the 3 in the tenths place is a 7. And then we have our decimal, and the 2 and the 2 is 4. So now we have 4.7, and then we'll go to the next two numbers. And we have a 1.7 and a 1.8. The 7 and the 8 make 15, so we'll draw the 5. And then we'll have to carry the 1 and add it to the 1 and the 1, which means 3. My pen is not perfect here, but this is a 3. And the next one that we have, all right, it's a little easier using my finger instead of the stylus. So that's a 3. Okay. Then we have the 2.7 and the 2.6. And when we add 7 and 6, we get 13. So we want to draw the 3. And then we're going to have to carry the 1 and add it to the 2 and the 2. And 1 and 2 and 2 is 5. And then the next ones are 1.9 and 1.5, which the 9 and the 5 add to 14. So we put the 4 and we carry that 1 and add it to the other ones, and we get 3.4. And then same thing here, the 1.2 and the 1.4. There's no carrying in this problem, so we can see that it is 2.6. And then the last two, same thing, no carrying, and it's 2.7. So when we have a problem like this, now we have less numbers to add together. And we can add them up if we feel comfortable adding this many numbers, or we can do the same thing again and make this into a smaller problem. So I'm going to add these two together, and the 7 and the 5 becomes a 12. Well, that's a very strange 2. And we're going to carry the 1 over here, and 4 plus 1 plus 3 is 8. And then we have our decimal place. And then here we're going to add these two numbers. The 4 and a 3 makes a 7 in the tenths place. And a 5 and a 3 makes an 8 in the ones place. And then we'll combine these two numbers. The 6 and the 7 makes a 13, which means a 3 in the tenths place. And we're going to carry that 1 and add it to the 2 and the 2 to give us a 5 in the ones place. And now we only have 3 numbers to add together, and we're much less likely to make a mistake when there's only 3 numbers to add together. So here we have 2 and 7, which is 9, and then we're going to add 3, and 9 plus 3 is 12. So we have a 2 in the tenths place, and we have to carry a 1 into the ones place. And when we add those together, we have 8 and 8 is 16, and if we add a 1, it's 17. And then we add 5, 17 to 5 is 22. So our final answer is 22.2. And that's an easier way that I found, if you're not using a calculator, to add up a bunch of small numbers. Because if you add up all of these small numbers from the original column, you might make some mistakes when you're adding them together over and over. To me, it helps to break them down into some smaller problems. So if we go to the answers, we'll see that the correct answer was C, 22.2. And that's the answer that you should have marked. So the next problem is that the dot plot shows the number of miles that Zach ran each day. And I think that the problem that we had in this question is that we just didn't read it carefully. So you have to make sure that you read each of your questions very carefully and figure out exactly what they're asking for. So in the first box, they want the number of days displayed in the dot plot. So the number of days, each day, some data is collected. So each one of these red dots is one day. So you would just basically count up all of the days. So distance ran each day, and then each day there's a dot. So if you ran 1 mile the first day, you would put a dot right here. And if you ran 1.5 miles the next day, you would put a dot right here. And if you ran 2 miles the next day, you would put a dot right here. And if on the fourth day you ran 2 miles again, then you would add another dot at 2 miles. And maybe the fifth day you ran 1.5. So these are not necessarily in order, but each of these red dots signifies one day. So we just count those up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 9 days. So this answer here would be 19. And then the next part of the question is the maximum distance. Okay, so what you did actually was you counted 1, 2, 3, 4, 5, 6, 7. You needed to count each dot individually. So I hope that makes sense. The next maximum distance that Zach ran on any one day. Okay, the next question, is the maximum distance that Zach ran on any one day. So you put 12.5, and I think that you misunderstood what it meant. So the maximum distance on any one day would be what is the most that he ran in one single day. And that would be 4. And the reason why is at the end of the day, Zach writes down how much distance he ran. If he only ran 1 mile, he marked it here. If he ran 2 miles, he marked it here. If he ran 3 miles, he marked it here. And then all of these other places. So the maximum distance in one day is 4. So that's the most he was able to run in one day. If he would have marked 12.5, it would be on the x-axis way out here, way beyond the range of this data. So it seems as though you may have totaled some of these when in fact you were just looking for what's the maximum that he ran on any one day. So the answer here would be 4